With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so our question is, two small bodies of mass 2 kg and 4 kg are kept at rest at a separation of 2 meter. Where should a particle of mass 0.1 kg be placed to experience no net gravitational force from these bodies? The particle is placed at this point. What is the gravitational potential energy of the system of 3 particles with usual reference level? Okay, so what we have been given in the question that two small bodies having masses 2 kg and 4 kg are kept on rest on a separation of 2 meter. Okay, so let us suppose here a mass of, let us suppose M1, that is 2 kg, and M2, that is 4 kg, is separated by a distance of 2 meters. Okay, now we have been asked that where should we place the mass M3 of 0.1 kg such that it will not experience any gravitational force between these bodies. Okay, so let us suppose that the mass M3 of 0.1 kg is placed at a distance of x meters from the mass M1. Okay, so the remaining length will be 2 minus x meters. Correct. Now, if the mass M3 is experiencing no gravitational force, that means the gravitational force experienced by M3 due to M1, let us suppose as F1, will be equals to the gravitational pull experienced by M3 due to the mass M2. Correct. So, when M3 does not experience gravitational force, then what we can say is F1 will be equals to F2. F1 is what? F1 is the gravitational pull of M3 due to the mass M1. Okay, so it will be given as G M1 M3 upon x square will be equals to F2 is G M3 M2 upon 2 minus x whole square. Correct. Now from here M3 and M3 got cancelled out, G and G got cancelled out, so M1 by x square will be equals to M2 by 2 minus x whole square. Correct. Now from here what we get is 2 minus x whole square upon x square is equals to M2 upon M1. The value of M2 is 4 kg and M1 is 2 kg, so it will be 2. Correct. Or what we can say from here is 2 minus x upon x will be equals to under root 2. Correct. So on solving this, we get the value of x as 0.83 meters. Okay, so we will place the mass M3 of 0.1 kg at a distance of 0.83 from the mass M1. Okay, now in the second part, what we have been asked is, if the particle is placed at this point, what will be the gravitational potential energy of the system of 3 particles with the usual reference level. Okay, so let us calculate the potential energy, gravitational potential energy, of pair of masses M1 and M2. Okay, so the gravitational potential energy U1 will be given as minus G M1 M2 upon R. Correct. So minus G into 4 into 2 upon 2. So it will be minus 4G. Correct. Now the gravitational potential energy for the pair M1 and M3. Gravitational potential energy of pair M1 and M3. So it will be given as U2 will be equals to minus G m1 m3 upon x, correct? So it will be minus g into 2 into 0.1 divided by 0.83, and the value will come out as minus 0.24 G. Okay, that much of joules. Okay, now for the pair of M3 and M2. Okay, so gravitational potential energy for pair M3 and M2. So it will be given as U3 will be equals to minus G M3 M2 divided by 2 minus X, correct? So it will be G into M3 is 0.1 and M2 is 4 upon 2 minus 0.83. So it will come as minus 0.34 G, minus 0.34 G joules. Okay, so what we can say is our gravitational potential energy of the system, or the net gravitational potential energy of the system, is gravitational potential energy of the system, that is M1, M2 and M3. Okay, so it will be given as U is equals to U1 plus U2 plus U3. Okay, now on adding this, what we get is U will be minus 3.06 into 10 raised to the power minus 10 joules. Minus 10 joules. Okay, so this is our gravitational potential energy. Okay, thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.